Welcome back. We just left off solving quadratic equations with complex roots, just like we see in the example on your handouts. Now we're going to look at on the back of your notes handout, so this is the back of your notes handout, how we can start to graph the complex unit, how we can start to see it visually, and we're going to call that geometrically, and also how we can use it with our symbols algebraically, right here. Okay. So, like we said back at the beginning, mathematicians said we don't have enough numbers to describe when we have solutions to polynomials that have these negative under the square root. So they invented more numbers, specifically called imaginary numbers, and now we need a way to graph them. So let's first look. Here is our real axis on our complex plane. So this is altogether called the complex plane. This horizontal axis is called the real axis. This is where we'll find all of our numbers we're used to, like the number 1, the number 2. We find our negative numbers on here. Negative numbers are real numbers. We also have numbers like pi. Pi is a 3.14. It's approximately 3.14, but it's a real number as well. It would be right over here on our number line. So this is our horizontal axis. That's where we find all our typical numbers. But to make space for all the imaginary numbers, mathematicians added on this other axis, this vertical axis called the imaginary axis. And this is where you find imaginary numbers, like the imaginary unit I, and then 2i. And there's all kinds of other imaginary numbers in here between, like 2.5i, 2.5i. Those are all imaginary numbers. There are also negative imaginary numbers. So this is where we'll find both our real numbers and our imaginary numbers plotted together. And so let's start to look at how we can manipulate our unit I and see what it looks like on the graph at the left. So algebraically, let's see what happens when we multiply by I. Let's say, what happens when we multiply by our unit I, imaginary unit I? Well, let's find out. So let's start with the number 1. I'm going to use black for this one. Start with the number 1, and let's multiply it by the letter I. Use light blue. So algebraically, I'm just going to multiply these together. 1i is basically just going to be the same as I. So when we take 1, I'm going to plot our number 1 here. When I take 1 from the real axis and it's multiplied by I, it transforms to the point I. So I'm going to plot the point I here where it ended up. So I'm going to do that in dark blue to keep our colors consistent. Dark blue. So something happened to this point 1 that made it move to transform up to the imaginary unit I. In geometry, we learned some types of transformations. Maybe this was a translation. That is, maybe it just picked up and slid over. Or maybe it was a rotation. Maybe it rotated around our axis to arrive at the new point. I wouldn't really say this is a dilation, because when we have a dilation, it should be getting bigger. Maybe it would be stretching out, moving away from that center. So it's not a dilation. We're trying to figure out if it's a rotation or a translation. Rotation or translation that took our point 1 to our point I. Well, the only way to be sure is to just multiply again and see where it ends up. So let's start with our point I, and let's multiply by I again. I times I. I times I. Whenever we have something times itself, that just means it's squared. Now, when mathematicians define this imaginary unit I, they defined I squared to be equal to -1. That's how we saw up in our examples before that when we had the square root of a negative number, only imaginaries allow that to happen. Only imaginary numbers allow that to happen. That is, mathematician said that I squared is equal to negative 1. So this is a really important identity, and we're going to come back to it all throughout the unit, and you're going to have to just know it. I squared is equal to negative 1. So right now, we had I squared, but we can simplify that. We know that I squared is equal to negative 1. So going back to our geometric picture over here, we started at I. I'm going to do it in red this time. We started at I, and we multiplied by I again, and then we ended up at negative 1. So now we're trying to decide, well, we multiplied by I the first time, our point ended up on the vertical axis. We multiplied a second time, and it ended up back down at negative 1. So now we're trying to decide, is this a translation or a rotation? Let's see if it was a translation. If it were a translation, the translation would have taken it 1 unit left and 1 unit up. And then if it were to be transformed again, it should have gone 1 unit left and 1 unit up. But it didn't end up there. Right? This is not where our point ended up. Instead, our point ended up back down here at negative 1. So that's why I'd say it's not a translation, and it looks a lot more like a rotation because it rotated 90 degrees. If we multiplied again, it would rotate 90 degrees. Let's check one more time and see if this is true if we continue to multiply by I. So let's take where we left off. We left off at negative 1. Let's multiply by I one more time, times I. Negative 1 times I is just negative I. I don't know how to simplify that anymore, so let's just go ahead and plot it on our graph. Negative I is right down here on our vertical axis. And certainly, it looks like we multiplied one more time. We rotated again to get to this point. So our big takeaways for this part of the lesson is that we know that I squared is equal to negative 1. So let's make a little note down here in our summary. We don't actually need this extra space. Down here in our summary, one important note is that I squared is equal to negative 1. That's going to be a really important identity that we come back to all throughout the year. Another important takeaway is that multiplying by I results in at first I'm just going to say rotation. Then let's see if we can go back and be more specific in complex plane. We saw it definitely made a rotation. How far of a rotation is this? Well, let's look. If I started here at the number 1 and I rotated up to the vertical axis, that is a 90-degree angle. That is a right angle. That's 90 degrees. So we multiplied again. It should have gone another 90 degrees plus 90 degrees for a total of 180 degrees. So it looks like each time this is actually rotating by 90 degrees. So we can even be more specific on our discovery. Multiplying by I results in a 90-degree rotation in the complex plane. So those are our two big takeaways from this part of class. And we will use them to compute powers later on in our classwork. So let's take a second, look over at your binder. On the second page of the lesson, we're going to look at how to calculate I to the 6th. So when we do this, we're going to do it both algebraically. So we're going to see how we can figure it out on paper. We're also going to do it geometrically. All right. So algebraically, things we know about I is that I squared is equal to negative 1. So we want to figure out a different value. We want to figure out what this value is equal to. I to the 6th equals what? We do know that I squared is equal to negative 1. So let's see if we can break this down into squares. Well, we have 6 i's here. I know I can take out at least 2 i's. I can pull out an I squared. How many i's do we have left over? Well, that means we have 6 minus 2, or 4 i's left over. So I can pull out another. And I can actually do that one more time. So all I did is I took this I to the 6th and I broke it up into 1, 2, 3 I squareds. We still have the same number of i's on both sides of the equation, But now it's in terms of I squared, and we know that I squared is equal to -1. So we can substitute in for each of these. If I go ahead and do that, again, whenever I substitute, I like to leave blanks because I know I'm going to be filling it in. It helps me keep track of my signs. So I go down here, I squared is equal to -1, -1, -1. So now we have the I to the 6th is equal to -1 times -1 times -1. Well, we can multiply this out. -1 times -1 is actually a +1. And then one more -1 on there. -1 times a +1 would give us a -1. So we've just shown algebraically, that is with equations and symbols, that I to the 6th should be equal to -1, using our key fact that I squared equals -1. Now let's try to do the same thing geometrically. Geometrically is in a graph, so let's just make a sketch. In this class, I don't mind that we sketch our graphs, especially initially. We can always go back and make our graphs prettier, but it helps just to get our ideas down by sketching. So I just made a simple graph here. We're going to be dealing with I, so put it right here. And our key fact over here is that if we multiply by I, we get a 90-degree rotation. All right, well, let's start here on this first thing. So we here, in I to the 6th, we multiplied by I 6 times. I to the 6th means multiply by I 6 times. So if we start at 1, if we multiply once times I, that takes us up to I. That's a 90-degree rotation. Well, we have 5 more to go, so let's keep going. Multiply again. That's I squared. That takes us to -1. That makes sense. Multiply a third time. That takes us to -I. Multiply a fourth time, and then a fifth time, and then a sixth time. That takes us all the way back here to -1. So we multiplied I, 1I times I squared, I cubed, I to the 4th, I to the 5th, I to the 6th, and it took us right back to this point, -1. So from this graph, we could say that I to the 6th is equal to -1. So we've confirmed both algebraically and geometrically that I to the 6th is equal to -1. So take a couple minutes, try out I to the 5th, see how we could use this process, and then we will come back for one last video to close out and wrap up our thoughts on this lesson.